Hey everyone, today we're continuing looking at optimizing our functions. So again, creating inequalities for a system and then looking at our vertices within our region to figure out how can we maximize profit or minimize cost. So very similar to what we did. The only difference now for today's stuff is that we're going to be given a paragraph or some information and we have to come up with our information. So you guys have the notes in front of you here. You can see what we're talking about. And then on the table, we have our different things that are included at our plan, right? So we have general labor. So just an FYI on what we got for general labor, this would be like basic stuff, right? So, you know, if you're looking for a summer job with no background in the industry, you'd apply for general labor. So you're moving pallets around, you're driving forklifts, you're, you know, picking stuff up from one pile and putting it into another pile. So it's very basic work. It's hard work, but it's basic work, and then usually it's not paid as well. And that's the difference then between general labor and technical labor. Technical labor would be something that's skilled, it's unique, so you're gonna be paid a little bit more. So that's how we would separate those, which is why we'd have different price points, okay? So within our information here, how we're gonna set up our stuff, first of all, a lot of times it's easiest to set up our objective function. And again, we are trying to maximize profit or minimize cost, which means we are looking for everything that has dollar signs. So our dollar sign stuff is going to be our objective function. And if we remember from yesterday, anything with dollar signs is our objective function. That's not what we're graphing, okay? So to create our objective function, right, like we said, okay, so same information here, just kind of broken down a little bit differently. Our information says it is $60 for plant A. So I could go 60A plus $50 profit for plant B. So this would be my optimized function. Okay, this would be what we are looking to use to maximize our profit. So this would be the equation we go back to at the very end after we've graphed our stuff. Okay, so now here's what we want to do. We want to come up with our constraints. Okay, well, first of all, since we're talking labor or hours, we know in real world problems, everything has to be greater than or equal to 0, right? So our time in A, or hours in A has to be greater than or equal to 0, B has to be greater than or equal to 0. Now, to come up with our constraints then, we're looking back at our original problem and we're looking for things that everywhere that say like up to, no fewer than, less than, right? Greater than, all of that stuff, okay? So here it says we can use up to 4,000 hours of general labor, up to 15,000 machine, up to 2,300 of technical labor per week. So that combined with our table here is how we're gonna come up with our information. So first of all, we have up to 4,000 hours of general labor. So if we look at our chart, now I know it's hard to see on our video, but you guys can see that on your paper there. We have A is 10 hours of general labor for a bike. B is 1 hour, okay? And we said up here, we could have up to 4,000 hours, okay? Now moving on to our machine time, we get 1 hour in plant A, 3 hours in plant B, and we're allowed up to 1,500 hours. Again, our constraints are what are we limited to? How many people can we hire? How long can we run our machine in a day? Those types of things, all right? And then lastly, technical labor, we need 5 hours per bike in plant A and 2 hours in plant B, okay? All right, so here we have then our constraints. And then lastly, let's go over to our graph here. So if you guys notice, these are the exact equations we just came up with. And I went ahead and graphed this already on your notes just to save us some time. So our feasible region, our shaded area, the possible number of bikes we could create is gonna be in that spot there. So what do we have for our pairs? Well, the only one I didn't label on your paper for you here was 0, 0. And part of the reason I didn't label that is because, well, we're trying to maximize. And if we have a manufacturing plant where making 0 bikes in either plant is our best profit model, we're not doing a very good job, right? So we can probably rule that one out. So now if we take our other ordered pairs and if we plug those in to our objective function, which again, we had 60A plus 50B, that was our function that we're dealing with here, okay? Our first ordered pair was 0, 500. So if we plug 0, 500 in, this would be 0, 50 times 500 would be 25 and 3 zeros, so 25,000. Our next ordered pair, we have 300, 400. Okay. When we plug that into our function, that would be 18,000 and 20,000, so 38,000. This one here, we have 380 and 200. We plug in 380 and 200, I believe we end up with 32,800. And our last one, we have 400, 0. And 400 times 60 would be 24,000. Oh, I'm sorry, I had my stuff off the screen. So again, we're trying to find what's our maximum profit. Our maximum profit would be 38,000, and that would be from making 300 bikes in plant A and 400 bikes in plant B. So that's the idea for today. Go through the problems and take a look at what we have, right? Anywhere we see dollar signs, we're gonna use that for our objective function. And then all of our stuff with less than, fewer than, greater than, no more than, that's the information we're gonna take and use for our constraints. Have fun.